unicorn, and then you have the whole emulator, and then you just do new unicorn instance, you load, you define some memory maps, and you load some firmware in there, and then you're good to go. So it's very, very convenient. So in this picture, we basically can build a firmware that uses our special HAL and our radio driver, and then load this into our unicorn simulation, and that can then talk to our Python environment. And so technically how this is done, I can maybe say real quick. So if the unicorn emulator encounters an SVC, an ARM SVC instruction, the software interrupt, it will trigger a callback, and then you're in Python world, and you can basically do whatever you want. You can do anything to the VM state, and you can do anything outside of it. So for example, if you want to send a packet, that would create an SVC instruction. The Python environment will see, oh, the simulation is sending a packet, it will take this and do whatever it wants with it. And so you can do something with it. We have a whole network library, so that means LoRaWAN network library. So we have a library that can basically do packet decoding, it can do all the key operations, it can do MIC verification, it can parse all the fields out, it can do join, it can generate join accepts and join requests and so on. So this library basically allows you to write all sorts of tests. Then we have a simple test script harness, which is just a way of writing test cases that can be then run in that environment. Then one really cool thing is virtual time, which basically means that if you are using this in a completely closed system, where you have no dependencies, or you're not talking to a real network server or anything, everything's running in this environment, then everything is completely deterministic, right? There is no external inputs at all. So you know that your next event that's going to happen is going to be in 5 seconds, for example. You know you have no work to do for 5 seconds. So you can start to compress your time. So if you don't have anything to do for 5 seconds, instead of going to sleep for 5 seconds, you say, okay, now it's 5 seconds later, and you continue. And what this allows us to do is we can now speed up the time it takes to do certain tests. So if we, for example, do a join, normally you do a join request and you wait 5 seconds, and then you send the response back. Now we can cut out all the waiting. So join request, pretend it's 5 seconds later, just do join accept and so on. So you can go through a whole battery of tests much quicker. And we've actually implemented the entire EU868 LoRaWAN certification test suite in this emulation, and we can run this in it's about 40 seconds or so to run the entire test suite. Then you also have the traffic trace, which basically is it can display all your traffic that's going back and forth, all nicely parsed out, encrypted, and so on, if it has the session. The whole thing is based on Python's async IO, which is the coroutine framework that comes with Python 3, I think since 3.5 or 3.4. And then you can write simple test cases. So for example, this test case is written for this join sample, right? So what we do here is we have, in this test framework, we have some utility functions available. For example, one of them is join. So what this function here does is it expects at some point in the future to get a join request from the device, and we will process that to generate a join accept and send that back down to the device using the parameters. And if any of that is not the way it's supposed to be, it will raise an assertion error and the test case will fail. And then I basically just go and go through a loop 5 times. I wait for an uplink. I make sure that it says hello, because that's the payload that we send up in that test application. I could also check that the port is 15, because that's what it's supposed to be doing. I don't cover that aspect of it. And then I check that the difference between now and the last time I got the last uplink is within the range of 5 to 10 seconds. We said it should send every 5 seconds. And the way we've implemented that is we schedule it after we receive the complete callback, which happens after the RX2 expires, right? So it's 5 seconds plus, plus at least 2, a little bit for the wait, and then maybe we have some duty cycling backup, so just say within 5 to 10 seconds is what I expect. And if that goes through, then I return true and that